Your what?
My other class, B100, starts this week.
Yeah, that's a fun one.
Is it a lot of work or not?
No. It's a lot towards the end. I mean, you just got a lot of writing.
No, I hate writing.
Or some. All right, we are live with Group 10, Lesson 11, no, Lesson 12. And we are short one person from our group, Ryan Skinner. So we got Ron King, Brandon Hopkins, and Peter Babcock.
The one and only Peter Babcock.
All right, good times.
Oh man, this is 19 questions.
Oh boy, yeah, this is going to be a long one.
Yeah, seems like this work's getting harder and harder. Or it's just I'm getting lazier and lazier. Yeah, I'm just opening up all the Excel documents.
Yeah, did you guys find that T-distribution applet?
Yeah.
Okay.
Don't think I used it though.
Oh, you'll use it in the homework section.
Okay.
You go in and you do it, and it just shows you your p-value. But then you copy and paste it into your homework. All right, so 1, 2, true, true.
Yeah, I'm just opening the Excel documents. Okay. Okay, so you've got 9.
Okay, so it looks like we got to work out the formula first.
I got 2.
Hey, you're too quick for me, John.
Well, probably because I did it wrong.
No, because I'm trying to work out which formula to use.
Nope, it's 2. It's you want d bar minus 0, and d bar is 2.2. Then you want divided by the standard difference, deviation.
What was your standard deviation? 3.3?
Yep. Divided by
I
the
got,
square root of 9, which is 3.
yeah, so I got 2.
Okay. I just took those 3 numbers and punched them into the spreadsheet and got 2. I put in the mean, the standard deviation, and a sample size.
I left all my stuff at work on my little flash drive.
Hmm?
No, I created my own formula. Where did you punch them in, Brandon? Which document?
On the quantitative inference thing, the paired sample t-test, the summary statistics at the top, you can punch in 3 numbers there.
Oh, okay. I didn't even think about doing that.
Now, did you close it out and reopen it? Because it'll get rid of your formulas. Or did you put them up all at the top now? Did you?
I just put the 3 numbers at the top where you can input those, the mean and the sample deviation and the.
Did I go the wrong way?
See that works. So the D, I'm just going to try that quickly. Standard deviation was 3.3. N was 9. Oh yeah,
But,
I mean 2.2.
Not equal
Standard
to?
deviation. And T was equal to 2. Yeah. Okay.
Cool. Okay.
Okay, number 4. The probability is so probability. So my p-value is 0.081.
How did you do that?
1 minus
just changed-
0.0403. And your probability is going to be 0.9597, or your
Confidence
level. Yeah, 0.9597.
Yeah. So basically, you take, Brandon, to get the, it tells you there that the probability of attaining is 0.00403. You just minus that from 1 to get your confidence level. And then I just plugged in the confidence level and it gives me a p-value of 0.081.
Oh my gosh. Okay,
What did you
so
get?
what did you punch in for the confidence level?
0.9597.
Huh.
So, question on this, you guys used the quantitative inference procedures, and you typed in 2.2 for the
Yep.
mean, 3.3
Yep.
for the standard deviation, 1.1 for the number. Oh, no.
No, 9.
Yeah, that's where I messed up. 1 over there. Okay, got it. So you got p-value 0.959, or if we round up.
No, p-value. I got p-value of 0.0.
You mean confidence level of 0.9597?
Sorry, no.
I don't have that either.
Yeah, 0.040. Is that what you said?
No, what, for the p-value?
Yes.
No, my p-value is 0.081. That's obviously rounded up. Do you guys
Okay,
have
not
anything in
equal.
your variables or different?
It's the not
Yeah,
equal
not
to.
equal to. Yep. I think that's what it was. Was it not equals to? Yep, not equals to.
Yeah.
Yep. 0.080.
Yeah, well, rounded up.
0.081.
Yep.
0.081. Okay.
Okay, now we get to use the data. Woohoo!
Good times.
Let's plug this. Data A. Let's make sure that's data B. Tuck it in, no? I have so many Excel documents open. Oh man.
No. Copy.
There we go. Oh, that was stupid. Okay. Go back to the question. Significance level is 10. 9. Okay, not equal to. What is the test statistic? I got 2.
At 0.407.
Yeah, I've done something wrong here.
Oh, wait.
Perform
No, I have the wrong confidence level. 0.90.
I have T equals 2. Yeah.
What'd you say?
I have T equals 2 as well.
Oh, you got to take out your mean standard deviation, those things that you put in. 0.407 is what I got.
Yeah, that's what I got.
Yeah, okay. 0.407. All right.
And you guys put your confidence level at 0.9, right?
Yep.
Yeah. No, I put 0.1. Shoot, what am I doing?
Well, that'll be for the next
There we go.
question.
Okay.
As long as you have it before 6. So,
So what is P
0.89.
value? 0.689, yeah.
Yep.
Okay, so it's larger than, oh wait, we're looking at 0.10. Ooh, it's less than. Reject the null hypothesis.
Yep,
Tried to trick me. So used to doing 0.05.
right?
Oh wait, 0.10? Yeah, it's less than. Yep,
Suppose your alternative hypothesis is missing.
that's greater than.
It's greater than 5% or 10%.
Yeah, it's failed to reject. Man, I
Yeah,
gotta really think about that.
because the number's
Just
too
fail.
big. Right.
It failed to the reject.
So what is the answer for 7 is we reject it or fail to
No,
reject?
failed to reject.
Fail to reject.
0.689 is larger than 0.10.
Yeah. So if the P is greater, you fail to reject. It's less you reject than all. Okay, suppose your alternative hypothesis is instead HA is greater than 0. What is your correct decision? So it is, that means P will now be less than. So we will reject it. We have sufficient evidence.
No. It's that's your alternative. So we still fail to reject the null.
Yeah, but you've got to change the type of test now to greater than.
Oh, let's see.
Your P level changes to 0.34. Still be greater though.
But that's still greater than, exactly. Yeah.
Yeah.
So it would be the second option, right?
We have insufficient evidence that the mean as it is greater than 0.
The number's too high, so we don't have enough evidence, right? So we don't reject the null. So that'd be the second one, right?
Evidence that the mean of the differences is greater than 0.
I have no clue.
We're staying with equals to 0 because the number was too high, so we're not rejecting the null, so we're staying with 0. So that's insufficient evidence that the mean is greater than 0, right?
Yeah, I have no clue.
The mean of the difference is greater than 0.
Okay, suppose your alternative hypothesis is
That's what most of the stuff was in the homework.
based.
Because saying it's greater than 0 then 0 is rejecting the null. The null is equal to 0. We don't have enough evidence to say it's greater than 0 because the p-value was too high.
I think you understand this better than we do. So I'm going to have to go with you. We have insufficient evidence that the mean of the differences is greater than 0. And the reason you say that is because we're rejecting the null, or the p-value is 0.344.
Because the p-value was so high, we're not rejecting the null, and the null was equal to 0. So we don't have enough evidence to say that it's greater than 0 because we're not rejecting the null.
And the 0 can still fall between the confidence interval. Okay.
Are we on this? We're the same on that one?
Yep.
All right. Okay, so number 9.
Get the stuff for B1.
B1.
Okay, I got n is greater.
We're also doing anything but 0.
Yeah.
99% confidence.
99.
And
I got that wrong. I'm honest. Yeah, I still got n is greater than.
Not equal to. And I have, let me see, what's the first one? Which is greater than, oh, n.
Yeah, I had n greater. I got n is 22 and df is 21.
Yeah. So what is the p-value? Let's make sure we all got the right p-value. I've got 0.001.
Yep, that's what I got.
0.001, yeah, that's right.
Okay, so what decision do you make? It is...
Well, it would be exactly the same, isn't it? Oh, no, it's not. The p-value is smaller.
It's less. Yeah, it's less than. We reject. You guys agree with that?
So no, quickly.
Less than 0.01.
Yeah, and 9 was n, right?
Yeah, correct.
Yes.
Because the degrees of freedom is always 1 less. Is that right?
Yep.
Okay.
Yeah.
And so rejecting the null on 11. Okay, yes. And this, now we're going to change it to greater than?
Yeah, the p decreases.
This is what got me on the homework. And I don't know if the homework answers were wrong, but it sounded like you were the original. You guys will see it when you get into the homework. You see, it had a less than, so I would have put in less than in there. But they showed that you, in order to get the, I'm just
greater than.
Yeah, but in the homework, you were looking for something that went down greater than to get the p-value correct. So I don't know if that messed me up thinking about this, but I mean I put in greater than just now.
Okay.
I'll find out afterwards.
So that decreased for everybody, right?
Yeah. So is that reject the null? So it gets even smaller. So it's.
Oh yeah. So reject the null. That's right.
Yep. Again.
Yeah. This is where I get stuffed. This question 14. I have no clue. I can just roll the dice here and get lucky.
Okay, so it's going to be the third one, right? It's the number's so small that we have sufficient evidence to reject the null, The null is 0, so we have sufficient evidence that there is a mean difference between the two groups. Right?
So
There's a
say it
mean
again.
difference?
Well, the p-value was so small that we're rejecting the null, right?
Yeah.
And the null equals 0, so it's going to be the one of these two that says there is a mean difference between the two groups.
Okay.
And since the p-value is so small, we have enough evidence to reject the null. So we have sufficient evidence that there is a mean difference between the two.
Oh, so let me
I get it.
see something. So if you look at the differences, the mean between the differences is 11.955. And so if you take 21.011, which is the higher confidence, minus 2.898 equals, divided by 2, and you've got a margin of error of 9. And so it's like almost 3 points beyond that 9. So yeah, I would agree with that.
All right, I have no idea what you just did, but you're agreeing with my answer? Is that right?
Yes, that's the margin of error that we have sufficient evidence that there is a mean difference between the two groups.
Cool, okay, that's what I got too.
Because it's beyond the margin of error. If it's below that margin of error, then it's like sketchy. You know, remember like in the politics, when you're in the voting thing, they say a margin of error of plus or minus 3. And so if it's a 47 to 53 or whatever, then they're basically tied. That's what they're basically saying.
Seems like you're making this harder than it needs to be.
Well, I can't. I'm like Peter. I'm having trouble understanding this. I think a little light bulb just went off.
Yeah, mine just exploded. Okay, so 15.
15.
Oh, 16, I mean. So it says which will give the smallest.
Oh, wait. What did we do on 15?
Did I skip 15? Oh, yeah. No, sorry, I'm working on 15 now. So 15, obviously, when it's greater, it's the smallest.
Yeah. Yeah. Okay, 16.
Yeah.
So we just changed the confidence level to 0.95 and look at the confidence interval, right?
Yeah.
Mm-hmm.
So what's that? Minus 13.304.
We leave it on greater than?
Yep. I have it bigger than.
Two groups. Put your answer below. What is the point estimate? Point estimate.
I don't understand this question.
Yeah, neither do I.
So isn't this the one where you change the confidence level to 95 and then you take confidence level 1 minus confidence level 2?
That would be the margin of error.
Yeah, is that the margin of error?
Or what is the point estimate?
Yeah.
Okay, I think I just Googled point estimate statistics, and it says it's the best guessed between the population parameters or between the confidence intervals. I think if we subtract the second confidence interval from subtract the first from the second confidence interval, we'll know exactly what's in the middle of that. I think that's the point estimate.
That's what I just did. Negative 13 point.
Cool.
I'm just reading back in the homework to see if that's right.
So we're talking 13.304?
Yeah, I got minus because you take the first one minus the second one.
Oh, the first one minus.
I took the second one minus the first one.
What did it say in Google again?
It said in Google, involves the use of sample data to calculate a single value known as a statistic, which is to serve as a best guess or best estimate of an unknown population parameter.
Anybody find where it says
you know what it is? It's 11.955. Because it says here that
It's the difference.
it's the different sample means. Yeah.
Yeah, you're right.
I just read all my notes.
The mean
What did you
difference,
find?
it says it right in the question, the mean difference. Why didn't we just look at that right away?
How does it say that there?
Yeah, it says mean difference right in the question. I don't know why we didn't see it. Oh, that's funny.
11.955. Yeah, I was reading through my notes and I'm like, whoops. What is the margin of error? I just read that.
Oh, that would be mine.
Half of the confidence interval, right?
Yep, 18 minus 5.303.
Yeah.
Close divided by 2.
Yes.
Margin of error is 6.652.
Yes. That's what I have.
That again? 6.652. Did you plug that into your formula that you got for it, or did you get it off the sheet?
No, I remembered it from what we were supposed to do last time when I missed it. Remember I stayed up
Yeah.
night to try and figure it out?
Okay, let me just work it out quickly because I got the formula here. The formula is equal to T times standard deviation divided by the square root. (22).
What kind of formula are you working at?
The margin of, is this the margin of error or the margin of difference?
Margin of error.
Yeah, so the margin of error is
the margin of error is always going to be half of the difference between the confidence intervals.
Yeah, you take the one interval and minus the other, and then divide it by 2. Or take the higher one and minus the lower one, and then divide it by 2. It's like what I was explaining with the political polls when they say a margin of error of plus or minus 3. So it's a margin of error of plus or minus 6.652.
Yeah.
Which, if your mean is 11.955, it's way beyond your margin of error. So that's what I was trying to explain with what Brandon, how he explained it, for me to understand it, that there is a difference. And it's beyond the margin of error, so it must be true. Okay, so input the lower bound. So input the lower bound of what? The confidence level or the margin of error?
Must be the confidence level. Well, either one would be it'd be the same number, wouldn't it?
No, it's either plus or minus 6.652 for the margin of error.
From 11.955, so it's going to come to 5.303 for the lower level, right?
Yeah.
All right.
So it's the same for either.
5.3, yeah. And it tells you at the top to make sure you have them in order. So the upper one is 18.607, eh?
18.607, yeah.
Yeah. I just worry about that question 17.
Well, we can find out right now.
That's the one that he pasted that, or he put that video on how to get
Yeah.
margin of error.
That's
He
right.
reiterated.
I wrote that down.
Yeah, I guess a lot of people got that wrong on that.
Yeah, I
quiz.
did. A few times.
I did.
All right, I'm going to turn it in and see what happens.
All right, let's see.
I think we did good. Good, 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 good. Ah, okay, 15.
We missed 15.
Yeah. Which
What did you
surprises
put
me.
for? What did you put for 15?
Maybe I put the wrong one. I put greater than.
Yeah,
I put
that's
the wrong
right.
one.
The fourth one.
Yeah, the fourth
it's
one.
wrong.
That's what I put. Marked it wrong.
Okay, so as we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
Greater than. Surely. Did you get any other ones wrong, Brandon?
No, that was it.
That's
Yeah, I
what
mean,
I
that's
thought.
the
I
one
would
that gives me the lowest.
say again.
That's the one that gives me the lowest.
Yeah. You're saying it's
Well, it
wrong.
says in general which alternative hypothesis will give the smallest p-value. Maybe it just means in general and not this specific problem.
Okay,
So
so not enough information.
Not enough information. Yeah, that's what I'm thinking.
Okay,
Okay, you want me to
retry
submit
that
with
one. Here you
Oh, you
go.
didn't do it.
I can do it.
Okay.
Boom, boom, boom. You are about to submit the quiz. Are you sure? Are you really, really sure? 100%.
All right, Brandon, you need to read these off to you.
Maybe. Let me see. Sometimes it leaves my answers in and sometimes it doesn't. 1 second here.
How tough is the homework?
It was busy. You had to do 3 sets of 3 sets of data and putting it in, and then
I need the answers again.
okay, where you want 3?
Number 3.
Okay, 3 is 2.
4.
0.081,
5.
0.407,
6. 7.
fail to reject.
8.
The second one, we have insufficient evidence that the mean of the differences is greater than 0.
9. 10.
0.001,
11.
reject the null hypothesis.
12.
Decrease.
13.
Reject.
14.
We have sufficient evidence that there is a mean difference between the 2 groups.
15.
The third one down, not enough information.
Oh, yeah. 16.
11.955.
17.
6.652.
18.
303.
19.
18.607.
All right. Let me just make sure. Well, I guess I don't have a choice. It's the second time around. Let's see here. %. All right.
100%.
Cool.
All right. We are
We're good.
good. So we will now stop the recording and I will submit, and we are done till Thursday.
I actually failed last week's quiz, the second quiz for the homework. I just totally blanked out and didn't put half the answers in for the second half. I just went blank.